when we don't like what's going on, and we'd rather not either see them, and like your example illustrates, we don't really want to talk about. I suggest we have to talk about these things if we want to maintain our integrity as individual scientists and as a profession.
Okay, I agree with that. As you pointed out, Ed, that there was a letter written to the Journal of Forensic Scientists with actual data, and the co-authors were George Sensabaugh, a former Founders lecturer who's here today, and as well as this person's postdoc who did the actual experiment that turned out to be so confusing for this distinguished scientist who shall remain nameless. But Ed,
even after that, you're gonna keep this person.
No, well, to be honest, Ed, I am working on a memoir, and in the memoir, I'm planning to name names, but I didn't want to do it here.
Well, thank you, Ed.
Are there any other? Are there any other questions? Yes, in the.
Well, this with PCR, it's one of the few developments in forensic science that ended up getting adopted very quickly, just probably due to some degree luck and having some of the right people in the right places.
That's not correct.
Mm-hmm. No?
It got adopted quickly because it started out being used primarily by me on behalf of the defense. And one of the major arguments, highly successful arguments, by the way, in getting judges to agree that the technology was generally accepted in the scientific community was the demonstration that the technology could prove that people that were accused were in fact innocent.
Right. I think what I meant sort of by luck, or more along the lines of the luck of the fact that you happen to be in the right place at the right time to basically.
Truly, there's a lot of luck with regard to that aspect of the
right.
situation. But in those days, there was a bias in the judiciary that basically took the position that we don't make mistakes when we convict people, particularly in California. I remember an admissibility hearing I was involved in San Jose, where testify about all of the papers that had been written and this, that, and presented a number of post-conviction cases as part of the proof of general acceptance. And the judge said to me, Dr. Blight, that's all very interesting, but in California, we could never have these post-conviction situations that you're talking about, these false convictions. And I looked at him and I said, Judge, just wait. And history, of course, speaks for itself.
So, was there more to your question?
Yeah. I was just kind of curious if in your observation, are there other techniques that you see that you would like to that you would hope that would be more quickly adopted by the forensic community? I guess more from a I guess genetic standpoint, that we're a little bit slower in adopting.
Yeah, no, I think the forensic community is slow in adopting because it's still an adversarial system, so that whatever is introduced, somebody has an incentive to challenge. And there are other judicial systems, where as I said earlier, where the expert witnesses testify for the court, rather than for one party or the other. But, as Sandy mentioned, I think next generation sequencing is a very powerful, exciting technology that I'm sure is going to have a big impact on forensics, and a number of commercial companies, including Illumina, who are putting out NGS kits, and I think that's great. So my hope is that will be evaluated in a more objective way, because as Ed points out, not everyone who challenged it had honorable intentions. If I can go back to the distinguished scientist who shall remain nameless, I think actually that was just a mistake, but it was a mistake that this person refused to take back, and therefore that letter that George and I and others wrote was necessary. But as Ed points out, many of the objections were pretty dumb, and were not based on good science at all. So I'm hopeful that those days, because I'm naive, that those days are beyond us, and that when next-gen sequencing is introduced into the court, there won't be spurious objections. I mean, as I mentioned, there'll be issues. How do you deal with background noise? How do you deal with the reliability of base calls and so forth? So there will be issues, but I hope there'll be scientific and technical issues. George?
I'll argue with that route to admissibility for PCR, but I think one critical factor was when judges' grandchildren were using it in their high school environment. That pretty much established that the judge must be legit. But
Come now, George, that wasn't the case in those early days.
not until about '94 or so, when the transition from RFLP to PCR was started.
We had gotten beyond the admissibility wars at that point.
Not really. It was not in my experience. But then we can talk about that with refreshment. But I think if I were to challenge NGS, I would question the process by which the samples are barcoded and put into the multiplex system for typing. Okay. How reliable is the barcoding? How do you know that sample X got the X barcode and sample Y as the Y barcode, and you didn't get them mixed up?
Mm-hmm.
And so there'll have to be some processes developed to make certain that you don't get those kinds of mistakes.
Yeah, no, there will have to be.
When you have the capability of analyzing 50 samples at a time on the same run.
Sure. I mean, that is, as George points out, one of the great powers of NGS is you can prepare libraries for many. We've done 192 different people in one run, and we think we can do 10 times as many. And they each have their barcode, so you then sequence them all together, and then the computer basically sorts each individual based on this barcode. I actually think that's pretty robust. The barcodes have been designed usually to be 8 bases or 9 bases or 10 bases long, so that it's, I'd say, very unlikely to impossible, to have a misincorporation or something that converts one barcode into another.
No, that's not the question. It's when you're barcoding the samples, how do you verify that the barcode that you put onto the sample is the barcode for that sample and not barcode
for some other. Question here? I'll come back.
A general issue comes up if you're not going to have an adversarial system as we use. Somehow we have to vet the evidence that goes before a prior fact, so that all the flat Earth people and people that don't believe in global warming and all the other things that scientists believe in don't get considered in a decision. So, what is the process for getting not only new evidence, but even the work done in any particular?
No, that's a very good point, because there's really two issues about reliability. Is the technology generally reliable and accepted by the scientific community, which is the admissibility criterion? And then in this particular case, how was the data generated, and is the data reliable? So I'll just use the O.J. Simpson case. I was at one time scheduled to testify in the admissibility hearing, but as you know, Peter Neufeld and Barry Scheck, who are on the defense team, used PCR and DNA typing in all of their Project Innocence work, or Innocence Project. So they basically stipulated that the general technology was reliable, so there was no admissibility hearing, and then the strategy was to attack, you know, the specific evidence that was presented in this case, and that's one way to deal with it, that have the issue of general admissibility done in a non-adversarial way, but then when the data is being presented to the jury, I think it's appropriate, you know, for one side to have an expert that says, well, the general technology is fine, but they screwed up here, and this is not reliable for reasons X, Y, and Z.
That's basically what the point George has made.
So, Ed, you...
Yeah.
Oh, okay. Yeah, but actually, let me ask someone who's not Ed.
That was a wonderful lead-in. I want to know what your thoughts are on your retrospective as we went through the process with DNA, looking at RFLP and the early dot lot programs, and then through the SDRs. Now we're going on to next gen. My thought is, first lead-in is that the process is consumptive and the material is fragile. So that we should be thinking as we go forward, how can we maintain all of this data that we're collecting? Let's go back to 1989 and we have RFLP as evidence, and now that case come up again in 2016. Can we even compare those values? My point is that we have superseded so many other disciplines. We should take that knowledge and build it in to wherever we're going so that we can maintain this and use it into the future.
Well, you know, I think many people developing new technologies try to have them backward compatible. So, you know, people who are developing NGS, they usually include STRs in their system so that, you know, the new data that they generated can be compared with, you know, STRs determined by capillary electrophoresis as well. But I want to come back, you know, Ed had a point or question.
The business about how do we deal with the new technology and this new technology that you've described, has part of the problem is simply newness. That's the point that the law makes. We're not going to admit things that are new that have not gone through some hoops.
Yeah.
What is the hoop that we want to go through and that is perfectly acceptable to anybody? Well, one of the liabilities of newness is a threshold level of experts in that new field that can provide the kind of peer review that is expected for rigorous science. So my recommendation would be, if you're going to bring something new into court, make sure that somebody else has the capacity to replicate your work.
Yeah. No,
Reproducibility, in
yeah.
other words, is the hallmark of reliability, and the legal test is this generally accepted as reliable in the scientific community? And if that community provides guidelines, or however you want to characterize it, but where the key factor is having the capacity to replicate the work that's being proffered, then you've met the criteria, and you should feel very confident of taking your work product forward.
Yeah, no, I agree. I think one of the reasons that PCR, you know, at the time I thought it was incredibly slow to get it accepted, but looking back, you know, it was really just a few years, was that when you and I and others were testifying at admissibility hearings, you know, we could point out that PCR has been used, you know, in medical, you know, to detect HIV, to do prenatal diagnosis for sickle cell anemia, to do HLA typing, you know, that it was being used very, very broadly. And I think will also be in a situation by the time NGS comes into the court, they point out that this is being used, for cancer diagnostics, for newborn screening, that the technology that's being brought into the forensics arena is being used extensively outside it. Now, one of the things that I remember is that opponents would say, well, sure, it's used, in the medical community and it's great, but you have pristine, that was the word, pristine samples. But, we deal with samples that are not pristine. And, it wasn't entirely clear to me what that mystical distinction was. But that was one of the objections, that they would accept that this is very reliable outside of forensics, but wanted to suggest that forensics was a unique application. But anyway, you're right, that it will be critical to have just more than one lab doing it, and I think NGS.
It's not. I'm not suggesting that every forensic laboratory simply say, well, we've got our result, now we're going to give it to our buddies next door so they can get their result. What I'm saying is that that potential, that is that capacity, that there's enough of the original evidence that's retained by the original investigating laboratory that they can say, if you want to challenge our work product, here's more evidence that's identical to the evidence that we employ, to have your own expert attempt to replicate our work under appropriate judicial supervision.
Yeah, actually that comes back to a question that was raised earlier that I think is very relevant, that if a given test consumes all of the material, you basically eliminate the possibility for replication. So I think
that's not a good way to start, I'm suggesting.
Yeah, oh yeah, no. So making the systems more and more sensitive so that they can use just maybe 1/4 or 1/5 or 1/3 of the total material would be very good, so that in principle, the potential for reanalyzing the same sample would be very helpful. Yeah.
Just a comment on a statement you made. Part of the mythical distinction between clinical laboratory operations and forensic science applications really deals with the critical thinking about the evidence you have, the amount of evidence that you have, and the best approach for analyzing that evidence. It's not so much with the methodology itself, but something that I think we need to protect is our ability to apply critical thinking as forensic scientists to the evidence that we have. You don't really need that in a clinical laboratory. It's a standard set of things. The samples that we get in the forensic labs are not standard.
Yeah. No, I think that's correct. Oh, Sandy?
I guess just a point back to, I would think in most cases you would have enough evidence to divide it and test it twice, but certainly in low template situations where the DNA is very limited, that might be an issue. So just posing the question, is it better to divide something in half and get a partial result, something like the New York lab tried, or is it better to consume the sample and get a reliable, try to get a more full profile on the first try than to try to divide it and replicate it?
Is that a question?
It's a